Alright, for our second example, we are going to graph f of x equals 4x squared minus 9 over x squared plus 2x minus 15. So, once again, first step, vertical asymptotes. So to find our vertical asymptote, we need to set the denominator x squared plus 2x minus 15 equal to 0 and solve. So this is a quadratic, and luckily there's no leading coefficient. So we can just ask ourselves what multiplies to negative 15 and adds to 2. So that's going to be x plus 5 times x minus 3. Make sure it still equals 0, and now we can use the zero product property. So we have x plus 5 equals 0, x minus 3 equals 0. So our two vertical asymptotes are going to be a negative 5 and positive 3. Second step is going to be horizontal asymptotes. So remember, for a horizontal asymptote, we need to look at the degree of our numerator and the degree of the denominator, which are both 2. So since 2 equals 2, we write an equation using the leading coefficients, which in this case is 4 and 1. 4 divided by 1 is just 4. So we have a horizontal asymptote at y equals 4. Third step, we need to find our x-intercepts and our y-intercepts. I'm going to start with x. So remember, we need to set our equation equal to 0, and we get 4x squared minus 9 all over x squared plus 2x minus 15. So when we multiply both sides by the denominator, we get 0 equals 4x squared minus 9. Now we need to add 9 to both sides. So we have 9 equals 4x squared. Divide by 4, and we are left with 9/4 equals x squared. Then we need to take the square root of both sides. Square root of 9. When we take the square root, we're left with plus or minus. Square root of 9 is 3, and square root of 4 is 2. So we have two x-intercepts. One's at positive 3/2. The other is at negative 3/2. So those are our x-intercepts. Now for our y-intercept, I'm going to do f of 0. So I substitute 0 into original equations. We have 4 times 0 squared minus 9 all over 0 squared plus 2 times 0 minus 15. So that gives us negative 9 over negative 15, which reduces to be 3/5. Right, negative divided by negative is a positive, and 9 over 15 are both divisible by 3. So that means my y-intercept is 0, 3/5. So now we are on step 4, which is to graph everything we know. So I made a 18 by 18 coordinate plane, and I changed my scale to be going up by 2. So you have to be careful of your scale. So since my scale is going up by 2, I'm going to make my vertical asymptote at x equals negative 5. So 2, 4, 5 is going to be in between here. So there's my vertical asymptote. Then I've got another vertical asymptote at 3, so 2, between 2 and 4. Actually, I'm going to make that a little longer. Now our horizontal asymptote is at y equals 4. Refreshing our memory, we've got, 3 halves 0 and negative 3 halves 0, so that's like 1.5. So if this is 2, this is 1, 1.5, no, like right here. Oops. Negative 1.5, somewhere around here. And then our y-intercept is at 0.3, which is like 0.6. It's going to be really low. I don't know what I keep doing. There you go. So this, I don't know, because we have vertical asymptotes, and it's looking like it's a little parabola almost. So we can go ahead, that was really bad. We can go ahead and make our curve. But we don't really know what's going to be on this side or this side. So to figure out those, we need to make a table. So remember, this is step 4 and 5. So when I'm making my table, I'm going to choose values to the left of this asymptote and to the right of this vertical asymptote. So we could do like negative 12. We could do negative 6. We already have values in here. If you wanted to, you could do more to make it more accurate. Sorry, this isn't so curved. This should be looking a lot nicer if I were doing this not on a screen. Anyways, so to the right of the x equals 3 asymptote, do 4, 7, 13, 20. So what we're going to do is just substitute these into our equations. So you can use your calculator. So 4 parentheses negative 12 squared minus 9, all divided by, you should probably put all of this in parentheses when you're doing it in your calculator. But for negative 12, you should get 5.4. For negative 6, it's 15. 4 is 6.1. 7 is 3.9. 13 will be 3.71. And at 20, it'll be 3.74. So now we can plot these. So at negative 12, we're going to go up to about 5.4. Remember our scale. So 2, 4, 5 is around here. 5.4, I don't know, around there. And negative 6 will go up to 15. And then if this wasn't good enough for you, you could find another point in between. I'm just going to say it's good enough for me. But I want to focus on the next side. So to the right of x equals 3, you'll notice we have at 4, we go up to 6.1. And then at 7, we go to 3.9. And then at 13, we're at 3.71. And at 20, now which is off the grid, but that's okay, we're at 3.74. So what's interesting about this is the left half of our graph, so the left side is obeying the horizontal asymptote, but the right half to the right of x equals our vertical asymptote, x equals 3, as the x values are getting larger, the graph drops below the horizontal asymptote, and then it approaches it from below. So you see how it kind of goes back up again? So remember, it's okay. Not every part of our function will necessarily follow the horizontal asymptote, but we do have one that exists.